Okay, we're ready to begin 15.4, multiplying and dividing radicals. And for you all again, we're only going to be talking about radicals of index 2, which is another name for the square root sign. So we're going to basically be using, just recall, we had if A for you guys and B are positive, and of course we're talking about real numbers, then the square root of A times B is equal to the square root, whoops, I overdid my sign there, the square root of A times the square root of B. And pretty much on our last exercise we were given the left-hand side and we produced what's on the right-hand side. Now we're going to be given what's on the right-hand side, and we're going to produce what's on the left-hand side, along with all of our simplification techniques that we've had. So with that in mind, let's just do some problems. So 1a, the square root of 3, notice 3 is prime, and the square root of 5, that's also prime. Well, that's equal to the square root of 3 times 5 by the product rule, which is equal to the square root of 15. And I already know I can't simplify it at all because 3 and 5 share no factors and they're both prime. B, we have the square root of 5x times the square root of 5x. Well, that's just another term for the square root of 5x squared. At any rate, I just wanted to throw that in there so you understand that the square root of 5x times the square root of 5x, that's a number, and I hope you can see from this right here what the answer is going to be. But we're going to use the product rule. It's 5x times 5x, which is the square root of 5x. Now look where the square is. Now notice, I just want to point out right now so you understand what I just did. This notation right here is just another way of writing the same thing. This is A, and this is also A, and A times A is A squared. This notation here, on the other hand, is the result of the product rule for radicals. That's how I got 5x times 5x underneath the radical sign. So two different things, but is it going to turn out they're interesting and related as to what the answer is going to be. So this is something raised to a power of 2. And the index is 2. So this is 5x raised to the power of 2 divided by 2, which is 5x raised to the power of 1, which is just 5x. So here we kind of learn an interesting phenomenon. The square root of anything squared is equal to that anything. So here I could have immediately gone to 5x. Instead I derived it using the product rule. And C, we have the square root of 2 times the square root of 6. Now notice there's no way I can simplify 2 because it's prime, and since 6 is equal to 2 times 3, and both of those are prime. But you're going to see in this example, when I use the product rule, 2 times 6, I get the square root of 12. But the square root of 12 can be simplified, because 12 is 4 times 3. So that's the same as the square root of 4 times the square root of 3. And the square root of 4 is 2. And the square root of 3 cannot be simplified because 3 is prime. And let's look at number D. Doing all kinds of things in this exercise. We're putting all kinds of past work together. Now here I have the base. That's 3 times the square root of x squared. So there's the power of the product. A times b to the nth power is equal to a to the nth times b to the nth. Remember that. And that's something we learn later, so you have to retain formula knowledge. And the hope is in mathematics you use it so much it's not so hard to retain. So this is equal to 3 squared times the square root of x squared. Well, 3 squared is 9, and just by what we observed in just a second ago, the square root of x squared is equal to x. So that's 9x. So here's a fact. The square root of any expression p can be a number, it can be a polynomial, it can be a polynomial term. The answer is p. So I just use that to simplify this part right there. And let's do E. The square root of 5x cubed times, notice all of that's under the radical sign, the square root of 15x. Well, that's going to be, I'm going to use the product rule. Now I'm going to multiply the numerical coefficients first, and then the x term second. What I'm going to do here to make things easier, well, 5, I'm going to break 15 down into its prime factorization. Instead of coming over here and saying 15 is equal to 3 times 5, I'm just going to break it down. And here x cubed times x is x to the 4th. So this is the same thing. Is 5 times 5 is 5 squared. Now I'm going to do something kind of different. I'm going to put all of the factors with even powers together. X to the 4th has an even power, 5 times 5 has an even power, and then I'm going to put times 3 out here at the end. Kind of looks weird, but that's okay. We can live with that. And some of you are ready to skip this step altogether. Now I'm just going to use 5x to the 4th. Split them back up again. So this is equal to 5. So from I no longer have to use the square root of something squared is just that something. And this is x to the 4 divided by 2. Now if you want to go ahead and put the 2 divided by 2 there, that's fine. Times the square root of 3. Didn't grab. So the final is 5 to the 1st power, x to the 4 divided by 2 is 2, times the square root of 3. Not so bad. None of math is really hard. You just have to remember all of these rules. And I guess that's probably, I think 2 things happen with math. There's an awful lot of rules to memorize, and you just literally flat out memorize them. It's best, I think, to memorize them by understanding why they exist and what brought about those rules. At least there's then some hope of you being able to rediscover those rules on your own. And trust me, it will happen. You will rediscover rules on your own. And when you do that, you should pat yourself on the back, because that's the first step of really getting math. So here we're just going to use the distributive property. Remember that one? So this is equal to the square root of 6 times the square root of 3 plus the square root of 6 times the square root of 2. And now I'm going to go ahead and use the product rule here. This is the square root of 6 times 3 plus the square root of 12. So this is equal to the square root of 18 plus the square root of 12. And you might say, oh goodness, there's more to be done. And I hope you are saying there's more to be done, because there is. Because the square root of, there often is, because these are specifically chosen, 18 is 9 times 2. And 12 is 4 times 2. So that's the square root of 9 times 2. So that's 3 on the square root of 2 plus 2 on the square root of 2. Now I can add those because I have like radicals. So that's going to be 5 on the square root of 2. So I'm going to pause right here because I heard something in the back that disturbs me. I've got to go check it out. So what happens, I will just tag to the end of this. Okay, I'm back. Sorry about that. It sounded like the cat was up on the back screen of the back door trying to get in which case something would have been major wrong. She loves to be outside and never does that, but she's out there asleep. I have no idea what it was. So let's look at G. So here we have the square root of 7 plus 3, so we're multiplying two terms. Oh, how nice this one is. Square root of 7 minus 3. So we're going to use the a plus b times a minus b formula. That's the difference of squares factorization. And it doesn't matter that you may be used to seeing it in a minus b times a plus b, because that's the same. These are two things. These are factor 1 times factor 2, and they're the product, and factor 1 times factor 2 is the same as factor 2 times factor 1. So in this case, a is the square root of 7. So that's the square root of 7, and it is squared. And b is 3, and 3 is squared. So the square root of 7 squared is 7, and 3 squared is 9. So the answer happens to be minus 2. So just remember, the square root of x squared is the same thing as the square root of x squared. And that follows by the product rule. We can actually prove that, because that's the square root of x by the product rule times the square root of x, which is another way of writing the square root of x squared. You'll be using that fact, in particular this equivalence right here, at the last part of intermediate algebra. So let's do H. So here we just have to do regular multiplication. It's not as bad as you're going to think. And so you can do this the FOIL way, or you can do it the other way. I'm going to do it the other way. I'm going to take, here's my first factor. So I'm going to take the first term in my first factor, which is a, 8 times the square root of 5, and multiply it by my entire second factor, 9 on the square root of 5 plus 3. Then I'm going to go back to my first factor and take my second term, which is a 9, and I'm going to take it along with its sign, plus 9, and then multiply it by my entire second factor as well. For this particular problem, foiling, if I were to use FOIL, it might be confusing. So I'd rather write this out here. So this is one thing times another. So now I'm going to use distribution. Let's just, so all of this times this and this, then all of this times this, and then times this. So for my first what I'm going to do, I'm doing 8 times the square root of 5 times 9 times the square root of 5. That's the same as 8 times 9 times the square root of 5 times the square root of 5, which is the square root of 5 squared. Then I'm doing 8 times the square root of 5 times 3. So again, we just multiply together the whole numbers times the square root of 5. Get some more room over here. And if you want to put the square root of 5 in parentheses, you can. And here, 9 times the square root of 5 is 9 times 9, which is 9 squared, times the square root of 5. In other words, I'm doing 9 times 9 on the square root of 5 is equal to, I'm using the associative property. Remember that from such a long time ago? Square root of 5. That's 9 squared times the square root of 5, which you can immediately write as 81 times the square root of 5 if you want. And then it's just 9 times 3, which is 27. So 8 times 9 is 72. The square root of 5 squared is 5. And that's a times there. It's not a minus. 3 times 8 is 24 on the square root of 5. And 9 squared is 81 on the square root of 5 plus 27. Go back over here. And 72 times 5. That's 360. Plus, now look, right here are like terms. So that's going to be 24 plus 81 times the square root of 5 plus 27. So let's collect my like terms. 360 plus 27 are like terms. So that's 387. And 24 plus 81 is 65 on the square root of 5. I didn't do this beforehand. I feel pretty confident that's right. Now let's check my answers here. 8 times 9 is 72. 5 squared is 5. 72 times 5, that's 10, 1, 35 plus 1, 36. 8 times 3 times the square root of 5. 3 times 8 is 24 times the square root of 5. 9 squared is 81 times the square root of 5 plus 27. I feel pretty confident that that's correct. And the last one. And we're going to use the formula for squaring on this last one. Number I. So remember, a plus b squared is equal to a squared plus 2ab plus b squared. That's what we're going to use. Except in this case, we're using a minus b squared, which is a squared minus 2ab plus b squared. So we're given 4 times the square root of 3 minus 8, and that's squared. So until you get used to it, it's absolutely fine to write a minus b squared is equal to a squared minus 2ab plus b squared. It's perfectly fine you do that. So here my a is 4 on the square root of 3 squared minus 2 times 4 on the square root of 3 times 8. I'm going to have to erase this stuff, but that's okay. The important one's already there. And then I have plus b squared, and I'm going to go ahead and square that. 8 squared is 64. So we have to look at this right here, and we have to simplify it. So let's simplify it down here. I'll just come right down here and look at it. And the first term we're going to simplify is 4 on the square root of 3 squared. Well, I hope you remember the power of a product rule says that's equal to 4 squared times the square root of 3 squared. And that's equal to 16. 4 squared is 16. And the square root of 3 squared is 3. So that's 16 times 3. What's 16 times 3? 18, 1. It's 48. So my first term turns out to be 48. So I can write it underneath here. That's 48. Here, 2 times 8 is 16. So 2 times 8 is 16. Then I'm going to multiply that times my 4. So 16 times 4 is going to be 64. I better do that. 16 times 4 is not 64, my goodness. 16 times, well, let's see, maybe it is. Yeah, it is. 64 on the square root of 3 plus 64. So what I have is, down here, 48 is my first term. 4 times the square root of 3 squared. Now, in simplifying, minus 2 times 4 on the square root of 3 times 8, I just wrote that as minus 2 times 8 times 4 on the square root of 3. And 2 times 8 is 16, and 16 times 4 we said was 64 on the square root of 3. And then I had plus 64. So these two terms are like terms. They're both natural numbers. So 48 plus 64 is 112. So I have 112 minus 64 on the square root of 3 is my final answer. Okay, let's use the quotient rule. Quotient rule will make a lot of these easier. So just so you know, here we are literally at the very last week of our semester, and the very last test that I gave intermediate algebra, they were using the quotient rule. So in a way, you're at the same topics as intermediate algebra. The only thing is intermediate algebra, we take each one of these topics just one step further, or maybe 2 steps further, but not too much further. So the better you are at this, you really, really will have a good foundation for intermediate algebra. So let's do 2a. So we're doing the square root of 12 divided by the square root of 3. So we always want to use our quotient rule. That's the whole point here. So that's 12 divided by 3. And the square root of 12 divided by 3 is the same thing as the square root of 4. And that's equal to 2. So here I have the square root of 50 divided by the square root of 2. You would get the same answer if you didn't use the quotient rule, but it's so much easier sometimes if you do it this way. So 50 divided by 2 is 25, and the square root of 25 is 5. And then our last one, the square root of 50y cubed over the square root of 2y. Well, that's equal to the square root of 50y cubed divided by 2y. Well, all I have to do is simplify this fraction. 50 divided by 2 is 25, and y cubed divided by y is y squared. And here, if you want, you can actually do it this way. 25 is 5 squared times y squared. I'm just doing it a different way. This is the way I have. It's a good way to learn it. And here I have, by the power of the product rule, a times b squared is equal to a squared times b squared. And again, we're used to going from my given what's on the left and going to the right. But now we have something on the right we want to go to the left. That's the same as 5 times y squared. And the square root of p squared is equal to p. So here, p in this case is 5y. The square root of 5y squared is 5y. Or if you wanted to, you could even write this as the same as the square root of 5y squared, and you're going to get the exact same result. So let's see what else we have to do. Oh, literally, that's it. So we just finished 15.4.